Okay. Good afternoon, everyone. So, this is our topic, no, for week 2 in business mathematics. So last time we talked about real numbers, no. So I didn't meet you last Saturday. It's because no, I have a very, I was sick time. Okay. So now we will discuss about linear equations and inequalities. Okay. So this will be our topic 2 for this course, business mathematics. Okay, or business 203 is mathematics. All right. So at the end of this lesson, okay, the learner should be able to develop the ability to solve these equations and inequalities accurately, then learn how to represent linear equations as straight lines and linear inequalities as shaded regions. Okay, so we will talk this later. Um, Particularly no and how to, especially for inequalities, no, how we can identify the shaded region and how we can use the straight line or the dashed line. Okay, that is for linear inequalities, but for linear equation it is very easy. No, we have to, or we just like to identify the y-intercept, no, the slope, in order for us to create a straight line. Okay, so linear inequalities, it is about straight line. Okay, so it's a if there's a curved line, so it's not linear equation. Okay, so learn to model and analyze real life situation using linear equations and inequalities, making predictions and decisions based on the solution you obtain. Then develop the skill to interpret the graph, then identify the slope and intercepts, and determine the relationship between variables based on the graphical representation. So introduction, okay? So linear equations and inequalities are fundamental concepts in algebra that involve linear relationships between variables. They are widely used in various fields, including mathematics, physics, economics, and engineering. Let's explore linear equations and inequalities in more detail. Okay, so linear equations and inequalities, they are important concepts in business mathematics, no? As they can be used to model relationships between variables, no? And solve real world problems. Okay, so a linear equation is an equation that can be written in a form ax plus by is equals to c. So where a, b, and c, they are constants, and x and y are variables. Okay, so the goal is to solve for x or solve for y, which represents the unknown quantity in the equation. Okay, so the solution to a linear equation is a single value of x that satisfies the equation, right? Okay, so a linear equation is an equation in which the highest power of the variable is 1. Okay, so meaning to say, our exponent here must be 1, and also our y. You cannot see that ax squared or by squared because we are still in linear equation, unless if we're already in trinomials. No? All right. So here, it can be expressed in general form as follows. So this is the general form: ax plus by plus cz plus dot 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 is equals to b. But actually, the general form of linear equation is ax plus by plus c is equals to 0. Then the standard form must be ax plus by is equals to c. Then the slope intercept form of linear equation is y is equals to mx plus p. Okay, take note that for linear equation, a, b, c, and etc. Represent coefficients, or they are real numbers. No, so a, b, c in linear equations, they are real numbers. No, they are non-zero. All right, so x, y or z example, so x, y, usually, for linear equation, it's only x and y. So they are the represent variables. No? They are the unknown quantity, right? So um, they are variables. All right. So now, to solve a linear equation, the goal is to find the values of the variables that can satisfy the equation. So the common method for solving linear equation is by isolating the variable on one side of the equation. The steps generally involve, okay, first is to simplify the equation by combining like terms. Second, move the terms involving the variables to one side of the equation. Next is combine the constant terms on the other side. Then divide both sides by the coefficients of the variable to isolate the variable. Okay, here's the example. So let's try to solve. For example, 2x plus 3 is equals to 7. The first thing you have to do is to simplify. No? So 2x, so simplifying, you have to transpose 3 to the other side. So take note that every time you transpose number from this side to the other side, or vice versa, the sign must be changed. What does it mean? If it is positive, it will become negative. If the number that you're going to transpose is negative, it will become positive. Like what happened to positive 3. When we transpose it to the other side, it will become negative 3. So as you can see here, 2x plus 7, no, 2x plus 1, 3 is equals to 7. Then when we simplify, meaning to say we transpose the 3 to the other side, so 2x is equals to 7 minus 3. So 7 minus 3 is equals to 4. So in order for you to get the value of x, you have to divide both sides by 2. So 2x, okay, I think we can annotate this one. Yeah, here. Let's say 2x, okay, so you have to divide both sides by 2. Okay, divide both sides by 2. So 2x divided by 2 is x. Then 4 divided by 2, okay, is equals to 2. So therefore, our value of x here is 2. But we're not done yet because we are here, or we're still here in the basic computation, or let's say example of linear equation. But actually, there are a lot of things we need to talk about linear equation, because linear equation consists with or involve graphing. Okay, let's say for example, 4x is equals to no, sorry, it's not equals, but okay, 4x 4x plus 2y is equals to 6. Okay, so as you can see, no, this is in standard form. Okay, the standard form is ax, oh, my bad. Okay, so ax plus by is equals to c. So that is our standard form. All right, my bad again. Okay, here. So C. So take note that A, B, and C are real numbers. X and Y here are variables. Now, all you have to do, if you plan to convert this into slope-intercept form, or let's say this is a standard form, okay? So this is SF, okay? SF means it's standard form. So let's try to convert this into general form. So how are we going to transpose this, or to make this into general form? Simply by following ax plus by plus c is equals to 0. So it can be it will be like 4x plus 2y minus, okay, so take note that as you can see here, positive 6. So meaning to say, if we transpose this to the other side, it will become negative. So instead of positive 6, it will become negative 6 is equals to, okay, 4x plus 2y minus 6 is equals to 0. So meaning to say, our standard form, oh no, general form, this is general form. So we can say this is GF, general form. Okay, GF, not girlfriend. Okay, so it's general form. So the formula for the general form is AX plus BY plus C is equals to 0. All right. So that is the formula for general form. What about slope intercept form? So for slope intercept form, it will be y is equals to mx plus b. Okay. So y is equals to mx plus b. Y here is the variable. The m here is the slope. Then the x here is also a variable. Then b is a constant, or let's say a real number. Okay. Or b here can be also the y-intercept of the equation. So let's convert this into slope-intercept form. So 4x plus 2y minus 6. So let's say we follow the how do you call that? We follow the standard form. Okay. So if we'll use the standard form, I think I better use another color. Okay, so 4x plus 2y is equals to 6. So let's see. 4x plus 2y is equals to 6. Okay. So ang gagawin natin, so we have to make this into slope-intercept form. So this is a general form, right? No, it's a standard form, not a general form. This is a general form. This is a standard form. So all you have to do is to make this into slope-intercept form. But how? So all you have to do is to transpose this 4x to the other side. Okay, transpose this 4x to the other side. And then get the value of, okay, so make the equation like to our formula here, y is equals to mx plus b. Okay, so all you have to do is to transpose. Okay, so 2y will be remain, so equals to 4x will be transposed to the other side. So since this is positive, it will become negative. So this will become negative 4x. Then copy the positive 6 here. Okay, my bad again. I don't know how to write using this one. But anyway, it's no problem. So it's positive 6. Okay, it's perfect. All right. So as you can see, now we need to simplify. Okay. Again, we need to simplify by dividing both sides by 2. So whatever number that you're going to simplify, that will be the number as the divisor, no, of both sides. So since 2 is here, so you have to divide both sides by 2. So 2 here also is 2, positive 2, then 2. 2y divided by 2 is equals to y. So you simplified it already. Negative 4x divided by 2, that is negative 2x. Okay, negative 2x. Then 6 divided by 2 is equals to positive 3. Now, our equation is y is equals to negative 2x plus 3. Now, our next problem is to how to graph this. No? So we need to graph this in order for us to identify, okay, the direction of the line, no, or what would be the line of this linear equation. Okay, so y is equals to negative 2x plus 3. So all you have to take down is the y-intercept. Okay, so in solving y-intercept, let x is equals to 0. Meaning to say, you have to substitute x by 0. Okay, so by using this y is equals to negative 2x plus 3, you have to insert the 0 to the x part because you need to let x is equals to 0. Okay, so solving, okay, y-intercept, let x is equals to 0. Okay, so take note this one always. Okay. Okay. Oh, hold on. Okay. Okay, now. So linear inequalities. Okay, so 4x plus 2y is equals to 6. 2y. Okay, so we simplified it already. So by solving y-intercept, you have to let x is equals to 0. Okay, so there's a problem here. Now, um, substitute. So y is equals to, okay, negative 2x plus 3. Okay, so you have to insert the 0 to the x term. Okay, y is equals to negative 2. Okay, insert the 0 here because you need to let x is equals to 0. Okay, 0 plus 3. Okay, so negative 2 times 0 is equals to 0. Then our remaining number is 3. Therefore, our y-intercept is 3. But if you know already the process in linear or in getting the y-intercept of linear equation, you can easily identify the last term or the constant or the single number of the given linear slope-intercept form is will be the y-intercept of the equation. So here, y is equals to negative 2x plus 3. If you know already the process, then you can easily identify the 3 as the y-intercept. But what about the slope? So slope here is the m. Okay, so m. So our m is the slope. Now, all you have to do here is to get the formula of the slope. So our slope here automatically is, okay, it is negative 2. Okay, so take note for our slope. Okay, slope. Okay, so I'm sorry for my writing. Okay, so slope is equals to rise. Oh, sorry. Redo. Rise. Oh, it's my bad again. Okay. Rise over run. All right. So what does it mean? Okay. So for rise, okay. So our slope formula, which is the m, okay, let's say it's m or slope. So rise over run. So all you have to do is to how do you call that? Identify if it's rise or run. Okay. So speaking of rise, you can the direction of the point is going up if the slope is or the numerator is positive. Okay. So it will go up if it's positive, then it will go down if it is negative. So that is for rise. Okay. So rise. Okay. So now for run, okay. So for run, it will go right if it is positive. Then if it will go left if it is negative. That is for run. Okay, that is the purpose. Now, in identifying the slope here, our slope is equals to negative 2. Okay? Since that is a single number, meaning to say that all numbers, negative and positive, there must be a denominator which is 1. So meaning to say, this is negative 2 here, there is automatically a denominator which is 1. So meaning our run here is 1. Okay? So as you can see, our rise is negative 2 and our run is positive 1. So let's try to make a coordinate plane. Let's try to plot this here. Okay, now, so as you can see, 2 and 1. So in plotting, now again, in plotting a linear equation, we have to start from the y-intercept. So our y-intercept is 3. So we need to say, so it is along the y-axis. So this is x-axis, okay? And this is y-axis, okay? So we have to, since our y here is 3, you know, say starting from the 0, 0 point, this is the 0, 0 of the coordinate plane, then starting from here, you have to count 3 times going up since it's positive 3. But if it's negative 3, starting from the 0, 0, you have to count 3 times going down. So take note that it's positive, so you have to, starting from here, 1, 2, and 3. So the point must be here, okay, in this area. Now, after plotting the y-intercept, all you have to do also is to plot the slope by following the formula rise over run. So for rise over run, so you have to start with rise, of course, no? So for rise, it's -2. So we have to go down, okay? Go down starting from this y-intercept. So -2. So from here, 1 and 2. But if this is +2, example, we have to count 2 times going up, starting from this point, from the y-intercept. Okay? So take note that when you plot the slope, you have to start with the y-intercept. Okay? Or the point where the y-intercept is located. So now, it's negative, so you have to go down since this is process. If it's negative, the direction of the point must be go down. Huh? So here, 1 and 2. Okay, but don't put a point there. Instead, you have to also recognize the run, which is 1. So the direction of run is going right because it's positive. If it's negative, it's going left. Okay, so this is a process. So starting from here, 1, 2, okay, for rise, and then run, you have to count 1 going here. Okay, and this is our point. So if we connect the line, okay, so let's connect the line. And there you go. Okay, so that is our line for linear equation. So for this given, okay, so you may try this offline using different examples you can find on the internet. Okay, but if you have questions for this one, don't hesitate to message me now on my WhatsApp account, or you can even message me on Google Classroom. Okay, so I hope it's clear. So that is how we're gonna graph the linear equation. Take note that you have to master in graphing linear equation because later on for inequalities we have also to graph the same process with linear equation, but the application of the line, the identifying the shaded region, okay, can be also done by by plotting the points similar to how we plot using the linear equation. Okay, now so let's continue. All right. So linear equation, or okay, so here we're already in linear inequalities. So I think we can erase this one, no? So clear, clear all drawings. Okay, so I hope you can you took a screenshot no, of it. All right. Anyway, you can just review the video. If it's clear, then it's good. All right. So a linear inequality is similar to a linear equation, except that it uses inequality symbols. Okay. So less than, okay, annotate. So less than, greater than, less than or equal to, greater than or equal to, instead of an equal sign. Okay, that is the difference between linear equation and linear inequalities. For linear equation, we use the equal sign. But linear inequalities, we use less than, greater than, less than or equal to, greater than or equal to. That is, these are the symbols where going to use now for linear inequalities. So it represents a range of values that satisfy the inequality. So example, 3x plus 2 less than 8. Okay. So for this one, before we proceed this example, take note that in identifying the line that we apply in linear inequalities on the graph, okay, let's say for example for less than or greater than, okay. Okay, I'll just use another color. So example, less than or greater than. So we can, if we can see this now in the given linear inequality, the line must be applied on the graph must be a dashed line. Okay, a dashed line, right? So for less than or equal to or greater than or equal to, the line must be applied in the graph. When you plot the points of linear inequalities, it must be a solid line. Okay, solid line, but not this one. Okay, so it's a straight line, straight solid line. Okay, that is for less than or equal to, greater than or equal to. Now simplify example 3x plus 2. Okay, so 3x plus 2 is less than 8. Okay, so how to do this? So to solve a linear inequality, the goal is to find a range of values that satisfies the inequality. The process is similar to solving linear equations, but with some differences when multiplying or dividing by negative numbers. Examples, let's solve the inequality 3x plus 2 is less than 8. So first is simplify the inequality. So 3x less than 8 is negative 2. So as you can see, you need to simplify this 2 and transpose this to the other side, since this is the same, no, with 8. No, there's no variable beside. No, so unlike from 3x, no, we cannot add 3x and 2. So, but we can subtract 8 and 2. So that is why we need to transpose this one to the other side. So once this must be transposed, that's the rule that every time you transpose number from the other side to the other side, the positive will become negative and the negative will become positive. That's the rule. Now, so as you can see here, when we simplify the inequality, 3x is less than 8 minus 2. So as you can see, combined constant terms, so we combine them, 8 and 2. So we can subtract them. So 8 minus 2 is equals to 6. So 3x is less than 6. So divide by the coefficient by dividing both sides by 3. Okay? I think we can annotate this one as well. All right. So here, we have to divide both sides by 3. Okay? So x, okay, no, not this one. Okay, this one, we have to divide both sides by 3. Okay, and then 3. All right? So 3x divided by 3 is x. 6 divided by 3 is 2. So our after simplifying, no, the result is x is less than 2. But we cannot, this is actually not done because we don't know the real value of x, no, except if you still or you keep on texting him or her. Okay, that's the time that you can identify the value of your x. But here for linear inequalities, we don't know what is the real value of x. So x is less than 2. Okay, but we're not still we're not satisfied by this one. Okay, so we don't know what is the value of x. Maybe x is less than 2. But if we graph this, no, and identify that the value of x, let's say the value of x is 1. So 1 is less than 2. Then this is true. Okay? So in linear inequality, when we graph this on linear on the coordinate plane, no, if the statement is true, then the shaded region must be along with the point, no, where you use or which you use in substituting the variables. Let's say, for example, you use the 0, 0 point or 0, 0 of the coordinate plane, 0, 0 point of the coordinate plane. So if the statement later on is true, then the shaded region is where the 0, 0 is located. But if the statement later is false, okay, then the shaded region must be opposite to which or to where the 0, 0 point of the coordinate plane is located. Okay, that is how you're gonna identify the shaded region of the linear inequalities. But later on, I'll give you the example on how to solve that. Okay, I'll use different variables and different numbers or examples so that you can understand. Now, okay, all right. So let's continue. Okay, okay. So I think it's time for me here to give another example. Okay, in order for us to know what should be or how to identify the shaded region. So y is, let's say for example, y is greater than 2x minus 3. Okay, so this is linear inequalities. Take note that identify first the line. So what is the line to be applied here? Since as you can see, this is less than or greater than. So we need to say this is a dashed line. Okay, so that should be the line that will be applicable later on when you plot the points on the coordinate plane. Now, identify the y-intercept. So automatically, the y-intercept here is -3. Okay, our y is equals to, or y-intercept. Okay. So y-intercept. Okay, my bad. So yun na yun. Okay, so y-intercept is equals to -3. Okay, and our slope here is 2. Okay, our slope is m. Okay, is equals to 2. So as you can see, that's a single number, meaning to say that there's automatic a denominator of 1. Okay, unless if our slope here is a fractional form, then we can easily identify that the numerator must be the rise and the denominator must be the 1. But here it's single number, so we can just identify that the denominator is always the 1, which is 1. Okay, so let's say this is our, I think I better use straight line instead. Okay, here and here. All right. So try to plot the points. Okay. So again, when plotting the points on the coordinate plane, you have to start with y-intercept. So our y-intercept here is -3. All right, so I'll use another color. So it's -3, meaning to say that it's going down. Okay, starting from here, this is 0, 0 point. So 1, 2, and 3. So the point must be here, our y-intercept. But what about our slope? So it's 2. So there must be a denominator of 1. So 2 over 1. So starting from here, you have to count going up since positive 2. So 1 and 2. Then the 1 also for 1 is positive. So it must be here. Okay. Now, after plotting the points, you have to identify what kind of line. So it is, okay, so it must be a dash line. Okay, it must be a dash line. So let's use a dash line. Okay, okay, take note that this is continuous. Huh? So it's not so straight for me because I don't know. I can make it straight using this mouse. Anyway, okay. So after plotting the point and applying the line that is specific for this linear inequality, all you have to do is to identify the shaded region. Okay. So for me, every time I identify the shaded region is I use the 0, 0 point, which is the point located in the middle. Okay, this is the 0, 0 here. Because this 1, 2, 3, 4. This 1, 2, 3, 4, and this is -1, -2, -3, and so on. Here, -1, -2, -3, -4, and so on. Okay, so the number in between is the 0, 0. So again, if the statement later is true, then the shaded region must be the area where the 0, 0 is located. But if the statement later is false, then the shaded region must be in opposite region. All right. So here, now using this linear inequality. So y, okay, so y is equal, no, not equals, but it's greater than 2x minus 3. Okay. So substitute using the 0, 0 point here, 0x and then 0y. So meaning to say 0, so y is 0 is greater than 2 times 0, then minus 3. So copy the 0 here, greater than 2 times 0, it's 0, minus 3. So 0 is greater than negative 3. Okay? So here, identify if the statement is true or false. 0 is greater than negative 3. What do you think? Is it true or false? 0 is greater than negative 3. That's true. Okay? Because number below 0 are negative numbers. So, since this is true, then we use the 0, 0 point. Of course, automatically, the shaded region must be in this area. Oh, sorry. Okay? So, here, in this area must be the shaded region. Okay? Right. So, okay, so these are, that is how you're gonna identify the shaded region. So what is the purpose of identifying the shaded region? What does it mean? So meaning to say, if you identify the shaded region, meaning to say that all points in this location, no, in this area, all the points here are the solution of the linear inequality. And then here, all the points in here are not the solution of the linear inequality or of this given linear inequality. Okay? Is it clear, everyone? Okay? So if you have questions, please don't hesitate to ask. All right? So I hope it's clear. Okay. Now, just a recap. So linear equation can be graphed as straight lines and cardinal plane, where the x and y variables represent the horizontal and vertical axis, respectively. The graph of a linear equation is a straight line. Take note of that. Linear inequalities can also be graphed representing shaded regions of the cardinal plane. For example, the inequality y is greater than 2x plus 1 represents the area above the line. 2x plus y is equals to 1. So these are the basic concepts of linear equations and inequalities. They form the foundation of more advanced topics in algebra and have practical applications in solving real-world problems involving relationships between variables. If you have questions, don't hesitate to ask. Please message me in the comment section, or you can please leave a message in the comment section, or you can message me on my WhatsApp number. So it's 0966582157. Okay, so I'm waiting your message. Okay, so if you don't have any questions or clarification, thank you so much for your time. Have a nice day. Goodbye.